Okay, in this chapter we'll move away from exterior and move into interior lighting technique. We'll start by talking about direct lighting. And the first thing we should point out with interiors is that interior lighting talks about the relationship of forms, not so much the separation of forms that you may encounter with exterior lighting. There's one primary technique that I use over and over again with direct lighting techniques, and that's using a cubic point array. And this is basically, in essence, similar to an area light, but it's one that's art directable. So we'll show how to set that up, and then we'll cover the use of painted shadows. Again, kind of a vestige of the pre-GI days with direct lighting. So let's begin by talking about cubic light arrays, and this is a term that I came up with years ago to try to get a GI look without any kind of GI tool set. And this just uses an array of point light sources set at cubic decays. What we'll do here is we'll create, in an attempt to do a soft lighting, soft type of diffuse lighting, we just simply make an array of lights of overlapping regions of influence, and this diagram portrays that basically. And because the cubic has a very fast fall off, you can see here from the center outward, we're going to get very hot concentrated areas here and very kind of soft fall off. Hot concentration, soft fall off. And because of this, we'll get a natural shadowing into the corners of the room, or attenuation of light in any case. So this is not unlike that of an area light, as an area light does consist of a matrix of point sources. But the beauty of this is that the spacing of the points can be adjusted, the color temperature of the points can be adjusted, and their lighting intensities can be adjusted as well. So we can actually use this again to art direct the lighting a little bit better and to get some variation of temperature and intensity throughout the space. Now as we look down at the result of this image, this is a very old image of a theater interior, but again using that, and we can see that it does in fact provide a fairly rich GI appearance again with direct lighting. And here's another example of a simplistic interior model. Again, being able to move the position of the points allows you to indicate the highlights. So I was able to accentuate, say, some of the rounded corners of this space by the location of the points. And again, even in a GI situation, art direction still remains a problem, or a challenge, I should say. And in this case, it's much easier to do. Not to say, though, that this will ever be as photoreal as a GI simulation. GI certainly, for photoreal ends, will always remain the best. But you may find that for basic work, this is a great technique. So we'll go back to the Indian cave temple that we looked at in the modeling title, and we use this as a way to demonstrate the setup of this. So we'll go ahead and create a light as a point light, and we'll create this with a cubic. And a lot of people will fail to do this at the outset and find it's either very laborious to change this. This is not an attribute that can be changed in the attribute spreadsheet, or you may not find the proper result. So if you have trouble with this, always make sure that you are on a cubic intensity. And let's create that light. And let's go to top view now. And what I'll do with this is I'll place this out central to the space. I'm going to turn off my pick filters here, selection filters, and just turn on light. And I'm going to duplicate this light about the space. And I'll pick the two and duplicate them again. And this is a very arbitrary spacing, and as a matter of fact, I think the fact that this always will be slightly erratic is a good thing. Okay, now that we have all these, let's go ahead and look in front view, and let's raise them up. Okay, so this will be our starting position for this. Okay, what I've done is I've created a custom layout here with the render view kind of central and other views that I can place lights in. I've rendered an IPR view of this, and I can see that it's effectively pitch black. And that actually makes some kind of sense because we are in a cubic decay. So the decay value, even at intensity 1, is falling off so quickly that there's really just negligible light to be had. If I open up, pick all the light sources, open up attributes spreadsheet, and go to intensity column, I can change all the values at once. So let's raise this up to 100, and we'll find that still doesn't do much. Let's go up to 1,000. And here I'll finally begin to get some lighting. And of course, this is going to be based on the world size of your model in world space. This is built semi-large, so takes a large intensity, but if you have a very small model, it'll take much less, because this is, again, lighting decay is based in real-world distance units. But let's take this up even further. Let's go up to, say, 1400. And now we'll start to get somewhere. Let's go up a little bit higher. Okay, so now that I have that first beginning with that light, let's duplicate these, the light sources, and let's pull a bank down lower. And clearly I have some offending lights in the back region there, so let's pick those and let's delete them. Okay, well now I have somewhat of a start to this, and I can see that we have a lot of hot spots kind of emanating across both the top bank and the lower bank. So what I can do is take this in the front view and maybe pull these in a bit, and we'll do the same on the other side. And I can begin to reduce that. If I feel like I need some more lights in the back, let's take, say, one and place it back behind the stupa form. And this can now be, again, art directed with abandon. So that's the beauty of this, this technique. And again, if a light proves to be too hot, we can just take that particular intensity down. And begin to really direct this. There's no shadows in this space, in this render. Certainly, if we add shadows, we'll get a much richer look yet. I would not recommend calculating shadows from the point light. A point light actually calculates 6 shadow maps, and ray trace shadows will give a very odd, kind of too sharp of an appearance. Plus, you don't want to reveal the fact that these are source lights kind of floating out in space. If you have shadows emanating from these sources, it would become obvious kind of what the game is here. So for shadows in this kind of space, I would add secondary lights. This would be a great use for shadow lights that we just looked at, especially on these rocks and so forth, and a whole series of other key lights within the space to accentuate that. So now let's we'll do a full render of this and see how it looks. Okay, let's go ahead and kick off a render of this. And we'll see one of the best parts of this technique, and that's just raw speed. There's no heavy ray tracing calculation to be done here. There's no real shadow mapping calculation to be done, so it tends to be very fast. And this is set at production level with the Maya renderer, so it's chewing through rather well. A few things to point out about this. Again, there's a lot I would do here with still with the highlights here and the color temperature variation. I may add some noise mapping to the color channel to add some more erratic characteristics. I'd bring in, rim lighting perhaps on the side of the columns. There's a whole variety of creative techniques, but let's show another thing here, which is there's now a soft shadow appearing below the rocks. And this is a very, very simple age-old trick. of putting a plane up above the ground just by a fraction of an inch. And if we texture this, let's do Option click on the Y, or Control click on the Y transform, which is a nice little trick to move around in ZX plane. But in any case, here we can see all this is simply an alpha channel rendered of the top view of the rocks, and then taken in and blurred in Photoshop and brought back as an opacity map onto a very simple surface shader. So the surface shader just has a black color, and the transparency is driven by that blurred alpha of the rocks. And the other trick about this is this plane you do want to turn off under render stats cast shadow itself, because otherwise you would have a by the time you add shadows, you would have an outline of that plane, and you certainly don't want that. So there's one last thing I can do to improve this image while we're looking at it, and that's something that was covered on the prior DVD in the camera work chapter, and this is creating some camera perspective correction. And here we can see that the vertical columns are in fact canted. There is a third vanishing point in this image that's high above the top of the frame. And what we'd like to do is straighten all these columns out so that they do stand truly vertical. Our brain does create some correction for this perceptually, especially at these kind of low rises of verticality. So it'd be nice to enhance this perspective a bit by doing that. So let's go into the camera attribute editor, and let's look for film offset in X and Y. And again, this is explained more thoroughly on the other disk. But let's add a 0.2 value. And now let's go to our yaw pitch camera tool, and let's simply go down and take out that third vanishing point. And I think that did it. Now my columns are all straight. Let's go back to render view. We'll save this off and re-render again. One thing I didn't check for was where the horizon line was here. This may not be totally aligned with the prior, but we'll see. But already I can see that's a much more refined composition. So a bit of bearing difference too, but nonetheless a better image in the end. So that's what we'll talk about with cubic arrays, and I think you'll enjoy using them. There's never been an interior project that I haven't lit with them in direct lighting, and it's just a fantastic way to get everything feeling unified in a uniform light field, and one that can have, with a lot of cheating, a sense of GI to it. Okay, the next topic to talk about is that of painted shadows, and this is similar to what we just showed you with the ground contact shadow for the rocks. And this is basically trying to do a GI look again with direct lighting, but in this case using a variety of shader techniques. So this image is, if we look at this, we can see it has a lot of soft shadow built into the roof vigas. It has kind of shadow welling up in the corners, soft shadow underneath the bowl, and shadow at the base of these structures. And we can see that if we go to the next slide, this is what the shadows actually are. This is all rendered without any shadow casting, but with just simple painting. So what happened here was that there were screen captures made of the geometry of the roofscape. These were then taken into Photoshop, and pen paths were created to stroke an airbrush along this long pen path and create this texture map. Likewise, the major beams here were done with that. A hole was cut for the entry to the kiva, and then a circular ramp was made for the drop shadow below the bowl on a plate, similar as the ground contact shadows for the rocks. Also, the images, let's go back here, the pieces on the wall are nothing more than texture maps, but they have a slight soft shadow plate placed behind them, and that creates a bit of dimension to them and gives them a sense that that's a real object. But again, these are implied, or rather attached, I should say, in the shader as a layered shader. so that we'd have our base shader, and then above that there'd be a layer, say you may reserve for the use of dirt or something, but in this case it's used for shadow, and it's just a black layer driven by the opacity of this particular map. So again, a very simple but useful method to mimic the look of GI. This type of technique actually would be useful if you want to render a long GI render to get the appearance and then use that as a roadmap for how to follow it with direct lighting. Or of course it could be baked into a map directly for a true GI look. But again, one more option for you if you are going to stick with direct lighting. So the last few topics to cover with interior lighting using direct lighting is that of light linking. And light linking everyone is familiar with, but for digital sets and backgrounds offers a great solution. Direct lighting, unlike GI, has no light transport simulation to it, so it's hard to cheat the fact that light can flow around objects and so forth. So light linking is one method to alleviate that with direct lights. Animated light color channels will show an example of doing a firelight by animating the RGB channels. And then lastly, color mapping of lights by texture mapping the color channel is another great use for sets and environments for creative uses. So this image illustrates the use of light linking with direct lighting in environments where GI would faithfully recreate light wrapping, but direct will not. So in this case, there are point lights placed well down below this kind of central shaft, emanating a lot of richly hued light and fog. And in fact, with this sloping surface on the side here, we would get a sense of warm lighting washing across that angled panel. When in fact, with direct lighting, the lighting being placed on the flip side of this surface would illuminate the backside but could never illuminate the front. So in this case, what was done was a light was placed up above with a penumbra, just kind of gently illuminating that particular ring, and this was light linked to that particular light, and not affecting any of the other objects in the scene. So this is one way, again, for light linking to allow the use of a GI effect with direct light. So can be useful on occasion. So going back to the launch base image, this is a good example also of light color mapping. In this case, I needed to have a penumbra that was basically a custom layout such that it had a fall off and then drop down to a dark region to allow this incandescence to shine through, and then pick up again more gently back into shadow. So by texture mapping a light, placing it as a circular ramp, basically the penumbra can be achieved through a series of sliders as a grad and allowing this final play. So this is one example of the possible use of color mapping your light for custom penumbras or for custom light effects. The next technique I'll show is that of animated light color channels, and this can be a useful effect for environments that you wish to light via fire or flames. And in this case we have the American Indian Kiva model of the same image that we looked at a few moments ago. And if I hit 7 and look at this with the actual light color, I can see over a series of frames that it animates both the intensity and the color temperature of this. And this is actually very easy to do. Let's pick the color source and let's go into the graph editor. And we can see that RGB is simply randomized either with the RAND key randomizer that we looked at on the first disk, or simply just manually setting keys and moving them. And what this will do is create, within a certain tolerance of course, if we look at the delta here, we can see this is within a very narrow range, that will get a variation in temperature and intensity, and if you get your timing right, it will actually look good in unison with, in this case I think, particle fire. So let's look at the final render of this. So here in the final animation I can see a more proper resolve of the lighting color temperatures than the hardware shading that we just looked at. But I can see that this offers one solution to a fire-lit environment. A very cheap trick, but some of the best ones are.